It's honestly one of the most common and one of the most challenging aspects of JavaScript programming because it's detached. You can't just like debug or step through everything because at some point, everything that was currently executing is done and you're waiting on an event to come in. And once you get to that point, it becomes a lot harder to debug because there's a gap in the trace. That makes stack tracing a little bit trickier. It makes debugging a little bit trickier. Asynchronous code is when most of the weird bugs in JavaScript show up. Everything was fine until suddenly, point A was no longer connected to point B. So if we go back to our conversation about callbacks, callbacks are functions that are passed into another function as a variable and called whenever the quote another function decides. And it's that second piece of that final statement that really matters when we talk about asynchronous code. The fact that just because we wrote a function doesn't mean we're calling it. Somebody else is going to call it when the time is right. And that's what makes asynchronous code possible, is that just because, like I said, we pass in a function doesn't mean it gets called right away. So here's an example. We've got this callback URL fetcher that would go fetch something and then call the callback when it's fetched. We don't know and we don't care if callback URL fetcher is asynchronous. That decision is left entirely up to the fetcher function itself. So we have our callback here. We say, I want the data. And it could come back immediately. Let's say it was cached or something like that. It could also come back after a long period of time if it had to go retrieve a URL. In this example, our callback is synchronous. We get from local storage and we immediately return the result. We don't actually on the outside have any idea how callback URL fetcher works. We just know that the callback will get called when the data is available. And that's up to callback URL fetcher to decide when the data is available and when it wants to call the callback. Right now it's synchronous, but it could just as easily be made asynchronous with the use of a set timeout. As soon as you use set timeout, the JavaScript is going to place that function at the end of the event queue. So anything that was waiting, any IO that was happening, any clicks that were running, those all get to take priority, and then the items in the set timeout will run at the end. JavaScript is single-threaded, so it can only do one thing at a time. Once you use asynchronous code, you're effectively yielding the UI, you're letting other things take precedence, and then you can resolve this when it's convenient. Because we're looking at set timeout or process next tick in a pure node solution, we've effectively made our callback URL fetcher guaranteed to be asynchronous. In fact, if we took the time, we can make it so that regardless of whether it was a synchronous call to local storage, or we would actually call fetch, manage the response, cache the response, and store it, to the outside world, it would always look asynchronous. In order to have asynchronous code, we must always have a callback in some capacity. Without a callback, you don't have asynchronous code. And that's just because of the way JavaScript works. It needs to call a function to continue the running of code, and callbacks require functions, and asynchronous code requires callbacks. So if you ever have to deal with asynchronous code, you're going to be working in functions in some capacity. In this fabricated example, we've put everything into set timeout. As a general rule, if you're going to work with asynchronous code, it should be asynchronous code all the way down. If you start asynchronous, it should finish asynchronous. And we'll come back to the then keywords a little bit later, but just know that the then keywords are effectively callbacks in process there. And it's using something called a promise, which we'll be getting to here in a couple slides. But ultimately, promises are just another way of writing callback code, passing in a function that will eventually get called. You have no control over when, but whenever the calling function decides. And again, I left set timeout in as a good practice. Mixing synchronous and asynchronous code will cause you a ton of bugs. If you start writing code and it's going to be asynchronous, just know that it's going to be asynchronous the whole way through. There aren't really hard and fast rules around how to write asynchronous code, But some basic guidelines are, like I said, once it's asynchronous, it should just always stay asynchronous. And callbacks are going to be the primary tool. Yes, you could use a JavaScript function called generators to do asynchronous code. The majority of us will probably never have to write generators, and that's probably a good thing. They're a little awkward. The syntax is weird. They don't really, they're tough to debug because they run in separate fibers. Just generally, callbacks are much easier. And so again, the other rule is that the callback you pass into the asynchronous function gets called when the asynchronous function cares. These three rules are going to be really important, and we're going to put them into practice here in a little bit with some asynchronous code we're going to be writing. I want to pause there for questions because as we deal with callbacks, that sort of basic overview is going to give us the tools for talking about promises, which is one of the last big fundamental JS pieces that we're going to be covering today before we get to our practice exercises. All right, so let's come back to the then function. The then function that we saw with the fetch is what's called a promise. We use it twice in a single line, chaining together callbacks. So we have a .then, and after that we call .then. The thenable code is called a promise. There's a lot about promises that we're not covering right now that are in the learning docs that are worth covering and worth spending some time on. What we care about for the purposes of today's course is that promises are objects which have useful methods. They have a then method. So the promise will call callback value on success. It has a catch function that we can call, and the promise will call the callback with the error on a failure. And most promise implementations have a finally keyword, which allows us to, just like a try catch, call the callback after success or failure to do any cleanup operations that we need to do. When you get back the promise as an object, you will get back something that supports then, catch, finally, and you can actually use that code and put it into practice. So if we take our fetch and we expand it out, we can actually see the underlying functions here. Both named callback for simplicity. The first one takes fetch and then has a then, and it says, okay, well, given the response, return response.json. And response.json is itself a promise from fetch, which we can then call then on as well. And so now we have our JSON data, and that allows us to unwrap a fetch command using promises, chaining the then keyword. What's important is that, like I said at the beginning, then is a lot of syntactic sugar for a callback. In fact, the difference between promises and callbacks is so minuscule that you can take code that supports a callback and convert it to a promise. And we do that with the promise constructor. So modern JavaScript has a built-in promise object, which itself takes a callback. And this is where everything kind of comes together. So new promise, we're going to assign it an anonymous function, and that callback takes two arguments, a resolve and a reject. When we've been successful, we return resolve with our success value. When we fail, we return reject with our error value. What's awesome about this is we get to decide when to call resolve, when to call reject. The promise itself is inherently asynchronous, and we receive two callbacks for our promise that, as the creator of the promise, we get to decide when to invoke them. Any code that uses the promise is simply waiting with a .then to continue executing code, and it won't do so until we call resolve. So promise recap here, the new promise keyword creates a promise. And there's a resolve and reject function that's available for managing the promise's success state. Generally with promises, it's a good idea to return because that's a good way of saying I'm done. And we're going to actually put this into practice here. One of our last exercises before we get into the sort of collaborative coding is we're going to actually put it all together in the form of a promises exercise itself. So in your pens, let me go ahead and grab mine again, and I'll put the link in chat again for everybody in case they don't have it. So now we can actually open up Promisify. And the Promisify module, as you can see here, let me go ahead and open up my console. There we go. All right, so obviously we're gonna have a syntax error because we can't just assign promise to a question mark. But in this example, we've got a standard module, which is gonna do some stuff, and then it's gonna call the callback with error and data. So the Node.js signature, which is how this problem would be introduced, is a callback function that always receives two arguments. The first argument is an error if it's been set, and the second argument is data if data exists. If your callback is ever called with the error argument set, you can safely assume that the function in Node has created an error. What we want to do is we're going to write a function that allows us to take this standard Node function that takes a couple arguments and a callback and turns it into something that supports a promise. We're going to basically write a Promisify. It is a function that returns a function, and that new function turns our original Node call into a promise version. And I know this is a lot less code than we've seen before where it's completely stubbed out. We're getting a lot closer to what we see in a phone screen, where we're given a very basic template, we're given an area to code, and a very simple explanation here of how we expect the implementation to work without any additional details. Again, just like before, these will be exercises where I'm coding along with you. Everyone should have this open. We'll start going through this. This one I believe is about 15 minutes long. It's the last sort of directed coding where you're going to start playing with stuff, and then we're going to start moving into interview type questions that are based on JavaScript fundamentals. And we've got two of those here at the end of the lesson. They're practice problems that you'll also be able to try multiple times that should get you in a position where you start feeling more confident going into Module 2 when we start doing UI and DOM operations.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today